MIMM was developed in August 2010. It combines Mitsubishi Electric's mobile mapping technology and Keisoku Kensa's mobile imaging technology to improve tunnel inspection by reducing the time and work required. This system enables inspection of tunnels without the need for traffic control. The system distinguishes abnormal sections through the complex analysis of recorded imaging data and has brought reform to the industry. Since their introduction, MIMMs have been used in tunnel inspections throughout Japan. Two MIMM technologies enable accurate and swift operation. The first is the application of 12 high-resolution video cameras and 48 LED lights. This mobile imaging technology system features recording and power supply devices installed in the rear area. The system shoots 30 images per second as it moves forward to visually detect cracks on tunnel walls. High-resolution filming in dark tunnels requires uniform angle and brightness, and the device is set up accordingly. The second is mobile mapping system. A high-precision, high-density laser capable of 200 rotations per second is installed in the rear of the vehicle. Furthermore, 3 GPS antennas required for laser measurement are set up in a triangular formation. IMU, camera, and laser scanner are integrated and mounted on the top board in the front area of the vehicle. The high-performing laser is capable of checking distortions on walls, such as bumps and unevenness that cannot be detected with a camera. Combining these two systems enables the recording of all areas inside the tunnel and the identification of abnormal sections. Only 2 workers are required for this operation, the driver and the operator. Cameras and lasers are operated in the recording room at the rear end of the vehicle. Simultaneously, images, GPS, and laser-detected data are recorded. Requiring only 2 workers for this measurement leads to cost reduction. The MIMM measuring method is very simple. This is how it's done. Basically, the tunnel is measured 1 lane at a time, and so there is no need for traffic control. In the case of 3-lane roads, images are taken in 3 phases. The vehicle drives at 50 kilometers per hour on general roads. On expressways, the vehicle drives at 80 kilometers per hour. Speed can be set according to the type of road to avoid inconveniencing general traffic. Filming range is restricted, and LED lights do not affect oncoming and parallel vehicles. Full attention has been given to safety. For 2-way tunnels, 1 round trip completes the inspection. Inspection is performed efficiently in a short time compared to conventional visual inspection, and this leads to significant cost reduction. Images are combined by computer, and the composite will show a clear picture of tunnel walls and find cracks as small as 0.3 millimeters. String images captured by all cameras are pasted together to create an expanded image of the full length of the tunnel. Cracks are displayed in different colors according to size. Measurement data can be further categorized and managed. It is also possible to see secular change. Matching GPS position information and images enables extremely precise 3D form measurement. Distortions on walls are checked using laser-measured data. Red sections are where tunnel walls are pressed inward due to the weight of mountain soil. If cracks should form here, there is a danger of the wall peeling off. Location and scale of abnormal sections can be seen at a glance, which makes it possible to propose detailed inspections and repair operations. Moreover, analytical operations by computer lead to improved efficiency. Visual checks based on measured data are not neglected. After measurement, workers actually walk to locations with possible problems, which further increases the reliability of the data, and more accurate information can be provided. We offer service after sale. Making use of MIMM measuring technology, development of software to automatically bond image data is progressing. Image processing operations that had been performed in a division of labor style has changed to a vertical integration style consolidated into single software, which realizes comprehensive and efficient operations. This enables operators with little experience to create expansion plans independently. We can offer 3 plans: Premium, Standard, and Light, to meet quality and cost requirements. Applying MIMM technology enables inspection of tunnels other than for roads, such as railway tunnels. For example, measurements of railway tunnels that require speedy operation within a limited time require a lightweight, easily transportable high-performance system. SHIM was developed to address these needs. This system is so compact that it can be transported within Japan via home delivery service. Yet, SHIM offers high-precision images, swift and accurate 3D measurement data equivalent to MIMM. Furthermore, capacity has significantly improved over the MIMM, enabling measurement in places where GPS information does not reach. It also has upgraded location precision. The data obtained expresses laser point cloud as if taken by camera. The tunnel's clearance limit measurement can be checked simultaneously while performing crack inspection without coming into contact with obstacles or structures. Development of software using artificial intelligence is also progressing. This is the use of deep learning technology that is attracting attention worldwide today. This initiative or technology involves computers learning about crack information in advance, which enables them to automatically identify cracks. The objective of using AI is to have the computer perform operations that have been performed manually to reduce man-hours, human error, and dispersion in data. An enormous amount of data accumulated to date is independently analyzed to enable stable and highly precise automatic extraction. This technology can be applied to the processing and analysis of image, audio, and linguistic data. Improvement and verification is repeated to establish higher inspection support service. we succeeded in the development of a new laser data point cloud analysis method. This enabled simpler and direct expression of analytical results, making it easier for anyone to understand changes in the tunnel. This will make it possible to flexibly respond to increasing needs in the future. New technologies introduced here have potential to provide service via cloud. Offering inspection service on a global level, we intend to improve the quality of service and digitalization in domestic and international inspection operations. Keisoku Kensa will continue developing measurement technology with a focus on safety and security while improving efficiency and precision. MIMM will move forward with further progress.